Alright, so now that we have all the pieces to the puzzle, I want to see if we can solve one of these matrix equation problems. And we're going to use that original example that we had from one of the earlier videos. So take a look at this. I have for us that original equation, and I also have in the corner a reminder of what the A inverse formula is. We already found the inverse to this, but just in case it is already becoming fuzzy in your mind, or more likely just for good measure in repeating ourselves, let's find it again. So A inverse, first thing we need to do is find that fraction, 1 over AD minus BC. So we use the number on the diagonals, right? So 3 times 3, that's AD, oops, that should be 9, minus the number on the second diagonal, 2 times 4, that's 8. So remember that makes it 1, so that makes it 1 over 1, which is why that first fraction doesn't change our numbers much. Then we swap D and A, so that becomes, instead of 3 and 3, it's 3 and 3, so that's an easy swap. And then on the second diagonal, we switch the sign. So instead of 4 and positive 2, we have negative 4 and negative 2. So that gives us a solution of A inverse is really just 3, negative 4, negative 2, 3. Okay, gonna make another little squiggly line. Keep that information separate. Okay, so how do we use this to find what the value of x is? Well, remember, in any kind of equation, in order to get x by itself, we have to divide by that coefficient. So this is like a coefficient matrix. But we said when we talk about matrix multiplication, or just matrices in general, we don't have a method for directly dividing. Instead, we call it multiplying by the inverse. And it matters what size, or what side we multiply on. So we want to multiply by the inverse of A on the left side of this matrix. And that means we need to multiply by on the left side by the same matrix. So not only are we multiplying by the same thing, we're multiplying on the same side. So this will look like this. We take our inverse matrix and we multiply it by just our regular A matrix. Then we have x, and then we have our inverse matrix again, 3, negative 4, negative 2, 3, and then we multiply by our matrix B, 6 and 5. Now we already know, because we did it in the last video, that if I take these two matrices and I multiply them by each other, we get the identity matrix. That's the one with the ones and the diagonal, the ones and the zeros. That's essentially the same as just getting a 1. So these essentially cancel out, and all we're going to have here on the left is just the x matrix, which is good. That should look good to you because we're trying to solve for that. So now we want to know what's on this side. And the way that we find that out is by multiplying A inverse and B. And this is a 2 by 2 matrix. This is a 2 by 1. So our answer to multiplying these is going to also be a 2 by 1. So we have 2 positions, 2 rows, 1 column. Actually, I'm going to make that just a little bit wider so that we have a little more room. And we will, let me use a different color again. Oh, we already used blue. Let's use our orangey color again. Oops. All right, we take our first row and first column here. And so we have 3 times 6 is 18. And negative 4 times 5 is negative 20. So I have 18 minus 20. Then I want to find the second row first column. So we do negative 2 and 6 is negative 12. and 3 times 5 is 15. So that gives us the answer. X should equal -2 and +3. Now, if I were to take this information and put it in right here for this matrix, and I were to multiply the left side, I would get the answer 6, 5. So this is the solution to our matrix equation. The answer to matrix X is -2 and 3. And that is how we solve a matrix equation using matrix division, or more appropriately, multiplying by an inverse matrix.